Hello, my name is Hubert, and I'll be showing you how to use the ConjureSDF. It's an add-on made by Jao, and you can get it from his Gumroad and his Blender Market. There are links in the description. I'll make sure to include them. And what's important is you have to get Blender 3.3. So to get that version, you have to go to Blender page, go to the download on top. Then there's this looking for the Blender LTS. We go here, we scroll down, we go again to 3.3, and you just pick your version, Linux, Mac, Windows, whatever. I'm using Windows, so I will get this Windows installer or this portable, doesn't matter that much. Okay, so let's open up Blender. Let's just download it. I'm using the 3.3.17. And the first thing you want to do is go to the preferences, inside the edit preferences. Then we click this install button, and you want to find where is your version of the Conjure. I have it inside the downloads because why not? And I'm going to pick the I have the 0.1.1.4. I'm clicking the install button, and it looks like nothing happened. Now we have it, and what you have to do for everything to work basically is you have to install Modern GL. You just click it. Okay, it took, I don't know, 15 seconds. Then you click Save Preferences, and everything should work. I recommend for you to reopen Blender after you install the add-on, so we are sure that Blender installed properly, because I had sometimes problem with add-ons not being installed properly without the relaunch of the app. The first thing you want to do is delete the default cube, basically. We delete it, and we also don't need this light. Yeah, let's get rid of it. And now you can go to the N tab, and it's called N tab because we open it with N key, and there is this thing. And it says, oh great, Visa, switch to Conjure Vision. And Conjure Vision is basically a custom render engine that the add-on uses, and you can either switch here or in your default scene here. It doesn't matter where you switch it. See, because it switches either way. And then we have like viewport, settings, quality. I might go over it later, but they're not that important for you when you're modeling. They're kind of important if you want to make a render inside the Conjure Vision, basically. For anything to work, we need to add the CSDF root. And it's, how to say it, it's like a thing that configures your scene for the Conjure to work. So let's add the root. Before that, there's a more text. Then cast the spell we're off to commence conjuring. Yes. Let's do that. And we have this new menu here. There's a mirror. There's a flip direction. The mirror right now is made for the whole object, so you cannot flip like a specific boolean like in the Blender, vanilla Blender, basically. Then we can flip the. There's also smooth mirroring, so it's like we are mirroring on the. So we have this y-axis, right? And we are mirroring across this plane. This is our plane. And if we do smooth mirroring, we can make a basically like the smoothing coming from this plane and go from this side to this side. I haven't used that once. I don't think that's that useful for me, but you know, that might be changing. Now there's more text. Now add a CSDF primitive, and there's Shift A. So there is this basically new tab inside of Shift A pop-up menu, and it says CSDF primitives. And inside the CSDF, we work with primitives. So there's, I think, 14, 3, 5, 9. Oh, it's 12. Sorry. So we have 12 primitives. We have cube, sphere, ellipsoid. They're basically the same. We have cylinder, elongated cylinder, kind of the same. Capped cone, bicapsule, capsule coin, link, torus, and hexagon. I will go over quickly. about each one of them, basically. So let's start with the cube, and you might be thinking it doesn't change that much the viewport, right? Before we change our render engine to be Conjure Vision, so we have to change the renderer or our viewport, and you can either by default click the Z key and you get this render view pie or whatever, or you can click in the top right, there's this viewport shading, and click the render. And now, so there are two, how to say it, there are two UI parts of this add-on. One is in the end panel and one is in the object properties. To get this object property, you have to click on the object, our box, our sphere, our primitive basically, and then you go to this yellow icon. And if you scroll down, you will see that there's this ConjureSDF. And what I recommend for you to do is you click those 8 dots, you hold it, and you go up. So you make sure the Conjure is first. It's really useful for it, in my opinion. And we have a new stuff going on. Before that, in this menu, so we have outliner. It's basically this thing on top. It's basically an outliner for the CSDF. In Blender, we have cameras, empties, bones, armatures, I don't know, planes, whatever. And in CSDF outliners, we have only primitives for the CSDF. And we have unnest and next underactive. I will go over nesting later because it's kind of more complicated subject. Okay, let's click our object and we have new settings basically. Let me expand this thing, get rid of this, zoom in, and we have different operation. Right now, it won't change much if we change to different ones basically, because we need something to interact. If we have Boolean, we need two objects to interact because we are cutting one box into another box. And to make this box more rounded, there is this option to make it rounded. That's kind of self-explanatory. We have also solidify, and it works the same as the default Blender. It doesn't have that much in this state, but if you are cutting with it, you can make a really nice panel cut, basically. There's ignore mirror. As said previously, we have this mirror, and if you want to have something asymmetrical, like we are cutting hole here, and you don't want for this hole to be on the other side, we just click ignore mirror, and this cutter will ignore the mirror globally. We have keep primitive scale. I'll explain it shortly because it helps if you change primitives from like sphere to a box. Okay, so let's add another primitive. Unselect everything because if you select box or our initial primitive, you will be nesting the operation. And I don't want to go over nesting right now because, as I said previously, it's kind of more complicated. So unselect everything, Shift A, let's add a cube or whatever you want. Press G to move it, and you can also scale it and rotate it like default Blender geometry basically. And as you can see, we have this smooth edge going on across our operation, and we can change its strength with the strength. So like so. And I will be making my box more rounded, the second one, so there's a better distinction between them. And here we can change the operation. Right now we have union, so we are adding two things together. We can also subtract them, like so, with the difference. There's also a intersect. So we want, how to explain it? We want to be left out with the parts that are in both of those boxes. I'm not sure how this works, how to explain it properly. Doesn't worry about it. If you play with it, you will understand it basically. Then there's the inset, and it's kind of a weird one because we are kind of insetting this, and instead of a strength, we get a depth like so. So if we go really low, we can make those panel lines. But the problem with me doing panel lines like that is that you are still insetting, the geometry. But you know, it's still a nice way to do some weird stuff like that. And we can make this more round, less round. And now let's go over the blending modes. So right now we have this really smooth transition. We can also make it be chamfered, so there's only like bevel with one segment, I think. And we can also do reverse bevel. I mostly use the default one or sometimes chamfer. There's one case for you to use chamfer that I'll be showing shortly. And there's also no blending at all, but I don't recommend for you to click on this blending to be none, because if you have a lot of primitives, it will take the add-on to take a while to recompile the whole geometry of the primitive. So it might take you like 1 second and 1 second freeze, and it's kind of annoying. And what you can do is in the smooth blending, you can crank the strength to 0. And what it does is it sets blending to be basically none. And the nice things about it is it doesn't recompile the whole mesh. So we can go and like go from 0 to a 5, and it's really quick. And there's no freeze. Okay, let's move to this keep primitive scale. So if we have it unchecked, okay, before that, let's add a cube, another one. And I wanted that to be a new one because now the scale is 1, 1, 1. And if we change it to the cylinder, it's normal cylinder, right? But if we go to cube again and we make it like so, and we do cylinder again, it's still like that. So what it does is if we have this creep primitive scale unchecked, it resets the scale to 1, 1, 1 every time we change the primitive type. So now I have 2.311, and if I go to cylinder, I have 1, 1, 1. It's fine right now, and for the most case, I want this to be checked. And if I change to cylinder now, it's like that. Of course, the problem with this, I would probably want this to be rotated like so, like this, but that's fine, So that's for the keep primitive scale. The better example would be probably if you have a cupped cone like this, and we change the size to this, and we have this unchecked, and we change to cylinder. The top face is not the same as we have right now, and if we keep the primitive scale, the bottom face now is the same. So not as I wanted, but it's still good. Okay, so let's go over the primitives that we have in our disposal. I already showed the cube, so let's go over the sphere. Then the cube, except for that, we don't have the round option, because sphere is always round, right? And if we scale it, it's scaling all the axes. So it's, if I scale it to 2, it's 2, 2, 2. And I cannot scale it in the individual axes, like I only make to scale it at Z. See, the outliner shows it that I'm scaling it, but in actuality, I'm not scaling it. And to go around that, we are not using the sphere, but we'll be using the ellipsoid, and it's under there. And what ellipsoid allows us to do is basically do what we wanted, right? We can scale it like that, and it's perfect for those really smooth cuts like that. Looks nice, right? And again, there's no roundness. It's not that different from the sphere, except that you can scale it into the each axis individually. I think that's the way you say it. Then we have cylinder. There is rounded part, but it's only on those top and bottom faces that we can round more. And if you want to chamfer them, what I will do is I will move this or let's move this cylinder down. Let's make it smaller. And what we will do is pick this box and we will make the difference. And nothing happens because our box is first in the stack. And what it means is it will only affect things that are on top of it. Like in the default modifier, you know, if you want to mirror an array, we first mirror and then array. We don't array then mirror because we might get some weird results. Modifier stack order matters. Same with ConjureSDF. To fix that, we just click this arrow and we move it to the bottom of the stack because we have only two things in the stack. We can change the strength, but we want the really planar change. And to do that, we pick the chamfer, and now basically what we want, right? And the bottom face stays, you know, like this. If you wanted to make this cylinder be chamfer from the both sides, what I would do is move it down, scale this box so it holds the whole cylinder, and scale it on the z-axis so it doesn't go over the top faces, and we pick the intersect. And now, as we can see, we are getting what we wanted, kind of, right? There's some visual bug, but I guess that's fixed with the with the ray scale. You need to make it smaller, but that's fine. That's fine for me. I don't care. And that's for the cylinder, and like tricks with the cylinders, I guess. It's the elongated cylinder, and we can round it. You can scale it on each axis as you want to. Although if you go too much, you will get those really not cylinder-like shapes, but you know, like this. I don't know what this shape is at all. So same here. If you go really thin and your roundness is really strong, you just have to not this thing, this roundness. We have capped cone and cylinder. And the difference between capped cone and the cylinder is that with capped cone, you can change the scale of the bottom and the top faces, basically. So we can make something like that. And it's really nice thing to use this capped cone because we can, for this really nice cuts, let's use it like that. And it doesn't work because we nested it. That's my fault. Let's unnest it. And let's put the difference on bottom. And you might be wondering, how do I make this cut be in the center? Well, what I would do is go to the edit mode, even though I said to you that you don't go there because you cannot change anything, but we can select stuff. So we can click Shift S. Let's use cursor to select it. And now we have our 3D cursor here. Let's exit the edit mode with tab. Let's pick our difference and let's click selection to cursor. And now it's in the perfect center. And if you want to make this like the center of this face, so you can access later, you can go to Shift A and add a empty like that. And we can access this empty way faster than going to edit mode and, you know, accessing this face inside the edit mode. The next thing is the bicapsule, and the same thing as capped cone, but we can change the sizes of the balls that we have on top and on the bottom, basically. That's basically it. There's no rounded option because it's, you know, always round. The next thing is capsule, and it's different than the bicapsule. In that way, you cannot change the, you know, the ball on the top to be smaller than the ball on the bottom. Although we can make it longer and, you know, like flicker, and I guess the y-axis doesn't work. And if you go minus scale, so it's like minus 0.2, you'll get weird results like this. So don't go there. Be sure to check your scale if you have any problems with the Conjure. The next thing is coin. Is just a coin, I guess. And we cannot change the roundness on this part. So it's like a worse, I guess, cylinder. I'm not sure why this is there, but sure, why not? Then we have a link. You can change the roundness of it. So if you go really big, we have a sphere. Again, as with the capsule, we can change the length, the thickness. The length is with the y-axis. The thickness is with the z-axis, S and Z. Then we can change the width with the X and the length with the Y. We have also a torus, which is like a donut, the donut tutorial. We can just make that donut with one click. That's the power of Conjure, right? And the last thing, we have a hexagon. That's basically a hexagon, right? We can use it to make like a screw. So let's add a cylinder, bottom, like so. Is it in the middle? Yes, it is. Let's make it into a difference. But the problem is it's on top of the stack, so we have to make it to be under the cylinder, like so. That's basically a screw, right? We have a screw. Then we can add a box. Now like this. We can do a difference, then a chamfer. But then you might be thinking, I don't want to chamfer this like the screw hole. So to do that, we change the modifier order. We want to firstly make this cut and then cut with this like a screw hole. And to do that, we just make sure the box is first and then our screw is second. And we get what we want. The next thing that I will go over is the limitation kind of a Conjure, and that is cutting at the same depth. So if we take this box, we duplicate with Shift D, and we move it right here, you see, even though they're on the same depth, this second box is cutting it further. So it's kind of a problem, and that's because this is, I think, a math shader. The CSDF is sign distance field, and it doesn't like when you cut stuff at the same depth. It's not a huge problem if you have more experience with this. I was never limited by this limitation myself, but it's something to look out for, and it's not like bug that you will have to like say, oh, I found this bug. No, it's just how it's supposed to work basically. Let me go over the nesting and what is actually because it's really powerful. And so let's add a cube with this sphere selected. Let's scale it, move it up like so. And let's also add a cylinder without selecting anything. And now what is happening is that we are adding this box only to the sphere. So if I were to change this box to be difference, I'll be, subtracting only from this sphere. Of course, you might be smart and say, well, this box is, before the cylinder, so it wouldn't be affected either way. Well, you're right. So let's click the sphere and let's put it on the bottom of the stack. It's the same, right? The box is still on the bottom of the stack, so it's the last operation, but it's affecting only the sphere. And that's basically nesting. We are telling the program to make the selected primitives affect only one primitive. So we are telling the Blender, cut only into the sphere and leave the cylinder. And with nesting, we can also create those really nice transitions that are kind of hard to achieve with SubD without a lot of work. So let's put this sphere on top of the stack and let's change the strength of this box. What we are doing is we are changing only the strength of this line basically, and we are not picking the cylinder at all. We can still change the cylinder strength here, but we can make it this really small, and then we can make the box really smooth, and we get this really nice contrast of this smooth transfer and this really sharp, transfer on the cylinder. And we can also make this into a, chamfer like this or like nothing, whatever. Of course, we can also unnest our cuts, unions, and so that you click the object that you want to unnest and you click the unnest button in the N panel under the CSDF. And we can also nest them. How to do that is we want to pick the object that we want to be on top, and then we pick the object that we want to nest it under. Okay. And with mirroring, it's extremely easy. We can just pick the axis. If you are not sure which axis to use, you can always, like pick randomly, or you can look at this gizmo that is here on top, and it shows you which axis you want to mirror over, basically. So let's pick the red one, which is X axis, and let's move it, and it works as intended, right? We can also pick the green one, the Y axis, and as you can see, it works perfectly. But let's say you want to have the cylinder only in this position, and you don't want it to be mirrored. And to do that, we just pick the ignore mirror one in the project properties panel, and now it ignores everything. And actual last thing is meshing. So we go to end panel, and there is this meshing part, and it's basically making our CSDF data a real mesh that we can texture and what's not, because we can change those Matcaps that we use right now. You can change to the render tab under here. Then you go to the Matcap. The Matcap is important because if you go to Studio and you change something like that, you'll get errors. And now you can use your custom Matcaps that you have installed inside of Blender. So it's really nice. And let's go to the meshing. Missing bounds can convert CSDF to mesh. So let's click this add bound, and we get this box with those empties. What is happening right now is basically we are creating this cage for the program to calculate the conversion. So for this works perfectly, but if we were to add the cylinder, make it smaller, and move it here, what would happen is our cylinder would be cut off here. And to make it fit, we have to move those empties, and the box will be created like perfectly, right? So let's go to the side view and move it to the right position. From this view, make sure to only pick empties. I would advise to give it some more room. Let's go to the side view, move it top view, it's fine. Okay, it's good. And we'll be getting 27 million triangles, sorry, voxels, which is too much for this object. So I'll be changing that density to 50. And now we can convert it to mesh. It will take 4 seconds. So 1, 2, 3, 4. Like 2, 6, that's fine. And now let's hide this original collection where there's the CSDF. And now we have our converted data in the CSDF mesh collection. As you can see in the outliner, in the Blender outliner, it's the green collection, and we have chunks. So basically the converters split our mesh, the CSDF data, into chunks. So I think it has easier times computing that whole operation. I might be wrong, that's fine. What you could do is, manually go and merge them together. But since the developer is so nice, we have this cleanup mesh chunks option. So let's click that. And this was really quick, although we lose some details, and that's because, as it's written here, after cleanup, remesh density and smoothing can be adjusted in modifiers tab. So you can see we have those 3 modifiers, and we can change its settings basically, but let's turn each of them. So the first thing we are doing, remeshing it once again, but with a modifier, and we can change the voxel size to be way smaller. Yeah, like so. So we are getting way better result. Then we are smoothing it. So we are getting way more smoother result, because as you can see, we get those really ugly artifacts going on here. And if we add a smooth modifier, it's gone. It's almost gone, right? If we zoom out, you just cannot see it, right? But without, you can still see them from the afar. So that's really nice. Then the next thing is a decimate, and we are decimating, so there's not a lot of unneeded geometry basically. Like here you see, we have this really flat plane. Unless you're animating, you don't need it to be, dense. as it is right now. So we are getting rid of a lot of unwanted faces and still keeping our curvature smoothness. See, the shading doesn't change at all, unless you change some settings like I did. Let's Ctrl Z. Okay, that's perfect. And that's basically it for the tutorial.